Students, welcome back to our third lecture of CSS2B. Today, we're going to be covering two important topics. One is learning how to create our own namespaces and what a namespace even means. And also, we want to do a little more review on overloading operators. But before we get into that, I want to take a step back and look at copy constructors. And to do that, I want to review the code from last week. So I kind of left this at the end of the last lecture, kind of on your own to see, hey, what's going on? What's happening? Run it, check it out. What's the deal with this code? So let's talk about it today. Let me bring that up. So here's our code. And the thing I want you to know is in the main, we have two objects, and we use a copy constructor for instantiating and initializing the second object. And then we go ahead and we print out both objects, we modify the first object, and then we print out both objects again. So what we want to see here is when I modify the first object, does the second one change? Let's compile it. Let's run it. And let's look at what we got. So we have our C1. There's that array size 10 within C1, right? We see that here. And we see that the constructor, when you use the overloaded one, should initialize everything to that value. Cool, that all makes sense. C1 is all 10, C2 is all 10s. Then we modify the first element of C1 and change its value to a 5. And great, we see that here as well. C1 has been changed to a 5, and C2 has remained unchanged. So everything worked well here. We were able to use the built-in copy constructor, and nothing bad happened. The code functioned as we expected. Now, if we are using dynamic memory, that's a slightly different story. So let's do that. Let's modify this code. So instead of using a array, it uses a dynamic array. So now I have a pointer to an integer. Not only that, but over here, part of creating the object is to allocate the memory for that object. So new integer array size 10. And then everything else should work the same. I'm not going to modify any other functions. All I've done is created a dynamic array whose memory isn't allocated until you instantiate the object. And the address of that array is stored at this pointer, and then the rest of the code works basically exactly the same. Now let's see what the result of doing that is. We'll compile, we'll run it. Oh, that was a little sneak peek there you probably saw, but let's see. So first of all, our arrays initially look as expected. The C1 and C2 array are okay. Then we modify the first element of C1, change it to a 5. And that looks great here. But unfortunately, C2 has also been modified, right? So this is a big issue. They are separate objects. If I update one, it shouldn't be updating the other one. But in this instance, it does. And that's because I have dynamic memory. I've got pointers. The default copy constructor only creates a shallow copy. So it went ahead and it took this pointer, C1, right? There was a pointer called array, which was an integer pointer. There was another object over here called C2 with its own pointer. And when this was created, it ended up pointing to that array, size 10. And by using the default copy constructor, this is the behavior we expected. Oh, okay. This will point to its own separate array, right, size 10. However, that is not what actually happens. So instead of doing this, when you do a shallow copy, Shallow meaning it only copies the pointer values. This ended up pointing to the same array. So when I use C1 to change this value to 5, since C2 is also pointing to the same one, it appears that its value has been changed to 5. Really, there's only one array right now. This one array is kind of being shared by both objects. And most of the time, that's not what we want. We want C2 to be pointing to its own array. That's why it's so important that we know how to write a copy constructor. So to write a copy constructor, this is the syntax. Name of the class, and its argument is a reference to the name of the class. And then you can assign values from the input object to the current value. So this is the parameter, because it's going to be invoked within that class. You can actually use this kind of dot operator without needing to invoke the getters, and you assign it to this current one, right? And for most of the variables that aren't dynamic, this is what you want to do. If there is a dynamic one, then you have to allocate that memory. One more thing though, not only do we want the parameter to be a reference to the class, but we want it to be a const reference. So this is what's going on. I don't need a whole copy of this class inside of this constructor, right? I only need a reference to it because I'm kind of going to copy values from that first. So it's almost like you would do a double copy. But if it's not const, then there is a chance that that object might be modified. So what we do is we pass it in as a const. Now you can't modify the original object, where we could have before, since the parameter was passed by reference, right? Reference gives us access to the original argument. And you should always have a copy constructor when you have dynamic memory, because the default copy constructor gives you a shallow copy. We just saw that with the dynamic array. If we wanted that to behave properly, we would need to write a copy constructor. And we'll do that here in a second. So the copy constructor is also used when using a function and doing a pass by value with an object as an input. And this is where we see it the most, actually, right? So if you have something like void my function, and one of the parameters here, so let's say there was a Korea class. So here, this would use the copy constructor. So this is another spot where the copy constructor is used that you might not realize. It was kind of obvious in our code that the copy constructor was used. Well, maybe not obvious, but more obvious here, right? Okay, there's a declaration of an object, and I see that the argument is another object, copy constructor. This one's a little more subtle, but this is the one that we're going to actually use a lot more. Okay, so let's go back to the test copy code and make a copy constructor. So it has to have the same name as your other constructors. It's a const test copy reference. We will call it TC for test copy. Awesome. We've added it to our header file. Let's go to our implementation file. I'll kind of keep the order the same, so I'll do it after this constructor. Okay, so what do we want to do now? Well, we want to kind of initialize this array separate from the other one. So how do we do that? This is a good starting point right here. So keep in mind, when we use the copy constructor, it's still a constructor, so we still have to allocate this memory for the new array. The second thing we want to do is we want to copy the values of this array here, so whatever array is in TC, to this array. So instead of saying init value, we will say TC dot, and look at that, we can actually access the array directly. Fine. And if you want to be non-ambiguous, you could say this as well in front of that, just to be extra sure that it's copying it to this one. So let's save it. Let's clear. Let's compile. Let's run it. Now let's look at our outputs. All right, great. So we see all of them are 10. We modify C1 to 5, and hopefully now C2 is still 10, and it is, because now that we have created the copy constructor, we've got two separate arrays. So now this is actually the case. That 10 is still there. When we print them out again, they are separate arrays, right? So that is the power of the copy constructor. Do I expect copy constructors to now make sense? You're all copy constructor masters? No, right? I still think that this is a pretty complex idea, but it's a tool we're going to have to need moving forward because we're going to use dynamic memory a lot. So for now, you know, kind of go along with it, memorize the syntax, even if conceptually things are still fuzzy. We'll keep getting more and more practice, and that'll become more and more clear. Let's get back to the lecture. And now we can talk about namespaces. So a namespace is a way to group code, so a lot of classes, functions together. And when we first start off with programming, we don't have our own namespaces, so we're able to just kind of include the using namespace standard line, which says, hey, if you come across a name that you don't recognize, use it in a standard way by having this namespace. So here's an example. String is part of the standard namespace, and you can either include using namespace standard, or you can add scope resolution by saying, by the way, string is part of the std namespace. Why might you want to do this? Well, let's say you work for a company and you want your own implementation of cout. Like when you use cout, it just prints out what's within the double quotes. But for whatever reason, this company wants you to include a timestamp. So not only do you print out the text, but you also print out a timestamp that includes date and then time, right? In addition to the message, right? So you would think, well, I can't use cout because cout is taken, but that's not true. Instead, you can just leave out using namespace standard, and based on which cout you want to use, you would just prepend. It's before? I'm not sure. You would have it before scope resolution operator cout. And if I wanted to use the standard one, then I would just write std : cout. So what are the rules for creating our own namespace? What's wrong? Maybe you guys heard that. My dog doesn't like namespaces, apparently. So make sure it's a descriptive name. For this class, maybe part of your name. Namespaces are typically all lowercase. Here's an example. Say you wanted to write a car simulation class. I might name my namespace Coria underscore car underscore simulator. So how do we create our own namespace? In your header file under your pragma once, surround the normal class declaration with namespace, a space, and then the name of your namespace. Then you add braces. What about the implementation? Go ahead and wrap up the entire implementation in a namespace. So see how if you got rid of this, it would just look like your class implementation would normally look. No big deal. And then your main, you could just add using namespace and then this new namespace you created. And C++ will know when it gets to that code that it doesn't recognize a keyword to look in those namespaces. I think now would be a good time to run this code. So let me transfer it over and I'll be right back. Okay, so again, here are our classes. We've got our namespaces. All of that's taken care of. So let's compile it. Let's run it. Excellent. We see the first circle has a radius of 0 and the second circle has a radius of 2.4. So we've got our namespaces. Now, what if we wanted to leave out this namespace? All right. So let's save it. Let's try to compile it. We get an error. All right. And the error is basically, I don't know what a circle is. Did you mean, and this error is very useful. It says, did you mean Coria underscore circle colon colon circle? Yes, I did, because that's where that class is defined in that namespace. So I save that. I compile it again, and now we can see it compiles and it runs normally, right? It runs how I expected to run. All right. How about this? What if I just eliminated using namespace standard here? It's not here. Let's get rid of it here too. So what would happen if I tried that? Let's compile. 4 errors. 4 errors, okay? So you can look for the errors. There's one in endel, there's one in cout, in endel, and again in cout. So the reason is that cout and endel are part of the standard namespace. So when I eliminated using namespace standard, it didn't know which cout I meant. So we can go ahead and bring them back like this. And at a higher level of programming, including lines like using namespace standard and bringing in an entire namespace is considered poor practice. It's called poisoning the namespace because now everything has that namespace. So generally it's frowned upon, but I think there is a happy medium, and let me show you the happy medium. So if you don't want to go through all the time and add, you know, std colon colon to cout to endel to strings, what you could say is using, right? So instead of bringing in the whole namespace, you say, this is how I want you to use cout as if it's part of the standard namespace, and this is how I want you to use endel. And it looks like I forgot semicolons there, which I don't remember they being there, but they must be because now it works well. So this is a nice compromise. You don't bring in the entire standard namespace. You say, okay, well, I'm going to use cout and endel from the standard namespace. Let me make sure that I include those here. Okay, and that brings us back to this part of the lecture. So test out the namespace by omitting the using namespace. We saw that, we tried it, we were successful, kind of neat. Const passed by reference parameter. Use it in function methods where the input is a class type. Why? This was kind of covered at the beginning, but objects can be really large, take up a lot of memory, and if you're calling that function over and over again, you're kind of just wasting memory if you don't plan on modifying that object. If you just plan on reading from it, it's a waste to bring it in as a copy. So instead, we'll bring it in as a reference. But by bringing it in by reference, we can now modify it inadvertently. So instead, you add the const. So that's why you have the const ref. Sometimes it feels silly. It's like, well, if you didn't want to pass it by reference, if you don't want to modify it, then just don't make it a reference and don't make it a const. But that creates a copy, and maybe I don't want a copy. So const ref is the way to go. Let's get another practice creating another copy constructor. The point3D class from the lab. We had these member variables. We had our accessors and mutators. We had a default constructor and 3-argument constructor. Let's define a copy constructor. So go ahead and pause the video. Take a moment. It should be 3 lines of code. Don't overcomplicate it. And then we'll go over it here in a second. So here, was it really necessary to write a copy constructor? The answer is no. we are not using dynamic memory, but it's just a practice. Basically, we are going to write what you get for free from C++. We're going to create a shallow copy. So we want to make sure that whatever values we have for x and y in P3D are the same values that are going to be part of this class. So no big deal. So this is the part I have an issue with my mouse. I don't want it to be up here. I want it to be down here, but now I'm off my tablet, so slightly annoying. Okay. Let's make sure I'm drawing. So we want to set, and I think maybe I had underscore x during the lab, but it's the setter for the x value. So I want the x from P3D. So P3D dot x. And I want y, this y to be the same y as the y from P3D dot y. If you feel more comfortable, go ahead and say P3D dot get x or get y, but it's not necessary because this is a point3D object. You actually have access to private member variables because you're inside another point3D. It's all good. Well, because you're inside of the copy constructor, I should say. It won't always be this way. And you can probably guess by now that this needs to be Z, and wow, that is a very bad D, but can we save it? There's no saving it. I think you get the point though. Okay, so that's another copy constructor. Now, what's going to take up the rest of this lecture and part of the next lecture? Overloading operators. We've overloaded operators in other classes, hopefully. So we have some practice. And let's go back to why we want to have overloaded operators. So it's, we can compare numbers using these Boolean operators, right? As 3.5 not equal to 4.5. 6 is greater than or equal to 4. And we thought, what about strings? Yeah, actually you can use it with strings too. Apple is less than banana. And then we started creating our own classes, and we thought, gee, wouldn't it be fun if you could compare, for example, if you had two car objects where you did stuff, and then you could say whether one car was greater than another car. And you can, using this syntax, in fact. So you get to choose, well, what do I want to compare cars by? What's my basis for comparison? Maybe it's a Kelley Blue Book value. So how much is that car worth? And that makes one car greater than another car. It's subjective. It's up to you as a programmer, and maybe more importantly, up to what the program is supposed to be doing. That'll dictate what you compare. But the whole point is we're writing classes, we're using objects, and we want to use objects like kind of the simple data type are used in terms of comparisons or arithmetic or input and output. That's what overloading operators is about, making your objects easier to work with by using operators that we're already familiar with. A lot of overloading operators just kind of remembering what the syntax is. Okay, so we're going to cover some more of that today. So let's say we want to overload the output operator. That one's useful. So instead of, writing, let's go back to this example. So instead of saying, for example, C1.print, which works fine, we actually used it on the last lab. It would be cool if we just kind of used it the way we're used to printing out variables. So why don't we write that? So we could write did I go too far? We could write a program that does that. And the easiest way to overload the input and output operators is to use a friend function which has access to all of the object's members, but it itself is not a member of the class. Here is the sample function declaration. Now, This is for specifically for the Point3D class. We're going to lean heavily on that here. And I'll bring in some code probably to show that off in a second. But in the declaration for Point3D, now again, I'll show you that. These are the words you would write. First, you would indicate it's a friend function. The return type is an OStream reference. The name of the function begins with operator, and then this will change based on what you're overloading. Because I'm overloading the couple names for this: the extraction operator, the output operator. Sometimes I'll say less than if those don't ring a bell, right? But whatever that operator or symbol is goes right here. And then we have our parameters. The first parameter should always be a reference to another OStream object. Then you can call it out or f out or whatever you want. Finally, the second parameter should be a const reference to an object of the class that you're overloading this operator for. Hopefully that wasn't confusing, but if I was overloading the car class, the output operator, the extraction operator, all of this would be exactly the same except here. Instead of saying Point3D, I would write car, reference, and then maybe a lowercase c or something like that to indicate that it's a car object. But that's the only thing that would change. Okay, so that would be found in the header file for Point3D. Then we would want to implement it in the implementation file. This is what that would look like. Now, some things to keep in mind. I don't have scope resolution here, right? Point3D : preceding the name of the function, because guess what? It's a friend function. It's not a member. I still want you to implement it in the implementation file, but you don't want to add scope resolution because it's not actually a member of that class. So let's figure out what would actually go in the body. So the key here is instead of using a cout object, we're going to use the out object. Okay. So now that we've got the out object there, now we just use it the way we would use a cout object. So if I'm trying to print out a 3D point, maybe the first thing I have is a parentheses. And then I want to print out the x variable. So I'll use Point3D. And again, you could say .getX, or you have direct access to it as a friend function. So I'm going to go ahead and use it because, hey, it's a friend function. Why not? Maybe a comma. And again, you just kind of keep doing what you would normally do if you were using cout, but instead, use the out object. Another comma. Finally, we'll print out the z component. Oh, and we want to close the set of parentheses and throw in a semicolon. Last thing, we have to return a reference to an OStream, so don't forget to return out. All right. One thing I always do is I leave out the endl, right? I could have had an endl here, an end line, but think about it. If I was printing out this Point3D in the main, right, like, you know, P2, and then I added an end line. If this already had a built-in end line as part of this overloaded output operator, I would get 2 new lines, and that would be annoying because that's not what I intend to have happen. So leave out any end lines, any new lines when you're overloading the output operator. What about overloading the insertion operator, the input operator? It's going to be a very similar situation. Oh, and with the other one, you also needed to include fstream, right? But you have friend, iStream reference, operator, different symbol for different operator, reference to an iStream in, and then we've got, this time, not a const reference. Why not const? Well, the whole point of overloading the input stream is to modify that object. So you don't want it to be constant, and you want it to be a reference, so it references the original value. Oh, and if we want to implement it, we can do that here. So the key here is to, oh, I'm sorry, that is annoying. Let's try it again. So the key here is instead of using CN, you use whatever you end up calling your iStream here. So I called it in. So there we go. This was called C point. Maybe P would have been an easier one to do for this example. But because, again, it's a friend function, I can directly access the private members of that class. So I can just say cPoint.x, cPoint.y, and cPoint.z. And there we go. Return your iStream object. Okay, cool. So take a second, try it out. In the code, I'll show you my code here as well. So here's our new main. And notice to enter x, y, and z coordinates, I can just use CNP1 with my point3D class. And to print it out, I can say here is the point, and I can include P1 in a regular output statement. So that's really, really cool. And let's look at how we did that. So in point3D, here's our friend function prototypes. And in this instance, I left off using namespace standard, which is why I have to include std : for each one of those. Here's implementations in point3D, which are the ones we wrote out. So now let's try to run this class. Let's compile it and run it, I should say. So let's say this is at 1, 1, 1, right? It's expecting 3 values. Here's your point, 1, 1, 1. Awesome. Let's say the next one is at, what would be good? Maybe 4, 4, 4. 4, 4, 4. And the distance between both points is 5.20. So I ended up implementing the distance this time inside of point, not inside, but as part of the point3D files. Notice here's the distance outside of the class. I think in the lab I did it in the driver file in the main. That's okay. Either way works well. And here I'm kind of giving you a throwback to, instead of using pragma once, I'm using the if and def, the define, the endif. But I just think it looks a lot cleaner when you use pragma once instead. Okay, and then here I am implementing distance. Cool. So we have some useful functions, some useful overloaded operators for point3D, but what if we want to scale a point? Well, if we want to scale a point, so be able to multiply a point by a value, we're going to have to overload the multiplication operator, the asterisk. And we're actually going to have to we're going to overload it twice. One for point3D times a value, or a value times point3D. And this is what the two prototypes would look like. And notice that the only difference is that parameters are reversed. What do I have to do that? Because of the commutative law of multiplication. I should be able to multiply them either way and have it work out fine. Here's the cool part. Basically, the code within them is going to be the same. So let's try that now. So here I've added both of them now to the header file. Let's go ahead and add them to our implementation file. Oops, I did not copy them, did I? Copy. And paste. Great. one thing you always want to do here is you want to delete friend keyword. That only belongs in the class declaration. You don't include scope resolution because it's not a member of the class. Now we have a couple of different ways of doing it. You want to, in either case, you need some kind of a temporary point. So we could say point 3D temp. And then you want to set its x to left dot x times whatever right is. And then you follow that pattern for y and for z. And then z. Finally, you want to return temp. So if you wanted to, you could literally take this, copy, paste it, change this to x, right? Because now left is your double and right is your object. And that works well. If you wanted to get really fancy, you could do it like as a one-line return statement where you declare the object and use the overloaded constructor. But I think this is pretty clear and works well. And this is kind of what we just did. When we scale a point, we multiply x by the scalar, y by the scalar, and z by the scalar. So now that that's in there, we could write a test program where we'll multiply one of them by 10.5, then the other one by 10.5, and then display both results. So go ahead and add that to your code, test it out, run it, make sure it's working well. So here's one way you could try to test it. We'll comment out this code. And here we can multiply times 10.5 and here times 10.5 as well. Just change the order. We'll go ahead and clear this. Well, let me make sure I save that. We'll compile. We'll run it. 1, 1, and 1 should give us 3 points that are 10.5, but I get 3 points that are 10. 2, 2, and 2, if you multiply each one by 10.5, should be 21, and they're all 21. So I've got a bug in my program in that all the points I believe I wrote as integers. Yeah, so see, I would have to go in and modify all of these so they are double in order for this to work out, right? Because when it generates the new point, it stores them as an integer, so I get some truncation there. So you might see that as well when you test it out. You're welcome to go into the point and point 3D classes and update them so they work with floating point values. Now, what about overloading the assignment operator, being able to do things like this? C++ also gives you that for free. But the rule again is if you have dynamic memory, you need to do this on your own because it's very much like copying the values from one object to another. And you would want to make sure you're getting a deep copy versus a shallow copy. So here's our format. Now this is a little bit different. I don't make it a friend function. I actually want to use the member function approach here because I'm going to be modifying the object itself. Okay, so shall we do this with the point 3D class? Sure, let's do it with the point 3D class. Why not? So let's go to the point 3D.h, and this is a member. So I would say void, doesn't need to return anything. Operator is a keyword. We throw in the operator we're trying to modify. And again, I'm just copying values from this other object. So I'm going to say point 3D reference, not 7. I forgot the shift key. Keep life easy. P. Okay. So again, if you're wondering, Mr. C, why are all of these friend functions and why is this one a member? In these instances, they returned, what they returned was different from the object itself. They weren't, well, I guess that's not the case with the iStream, but implementing it this way is easier. Could I have implemented the operator insertion method without it being a friend function? I believe so, but this is the easier way because it very much mirrors the OStream. So I would say for the arithmetic operators, for the input and output operators, make those friend functions. The assignment operator should be a member, so you can write that kind of down as a rule for you. All right, so let's implement this. And I'll just implement it here, why not? Because it's a member, this time I do need scope resolution. And I just want to make sure that when I set the value, it's going to look really similar to the constructor, the copy constructor. When I want to set X for this, I take it from the parameter. Okay. And I think that it's somewhat clear that the next two follow the same pattern. So I'm saying go to this point and grab its X value and set it to this X. This might be easier to see too. And if you really want to get rid of any ambiguity, you can use the this pointer. So those would work as well, but again, I'm a fan of using the built-in setters because they're already there. Let's minimize the number of functions or constructors that modify the object. All right, let's look at one more example of an overloaded assignment operator. This is what you would do for rectangle. And this example for rectangle and for point3D, those weren't the best. You wouldn't want to do those. You wouldn't want to overload the assignment operator because there's no dynamic memory being used. So C++ is going to do all of this stuff for free. It's already built in. You get those for free. But it's just good practice, right, to get into, not the habit. I don't need you to do this for everything, but it's good practice to know the syntax, the format. It would be a little bit more complicated anyway if there were dynamic memory because you would have to allocate a brand new set of memory and then populate the memory with whatever was in the parameter. Okay. All right. So a lot of good stuff thus far in this lecture. We still have some more overloading operators to discuss, but we'll do that in the next lecture. All right. I will talk to you soon.